Okay, geometry fans, our topic for today, we're going to look at section 8-5 a little bit more. We're going to do two examples using angle of elevation and depression. Now, before we begin, let me give you your joke of the day. What do you call a dog that can do magic? And the answer is a labracadabrador. All right, so the first example we're going to do, this is actually in your book. This is on page 611. This is number 8. Miko and Tyler are visiting the Great Pyramid in Egypt. From where Miko is standing, the angle of elevation to the top of the pyramid is 48.6 degrees. From Tyler's position, the angle of elevation is 50 degrees. If they are standing, that's angle by the way, if they are standing 20 feet apart and they are each 5 feet 6 inches tall, how tall is the pyramid? Now in the book, the picture is a little bit better than this, but this is basically what's happening. So you have, this is Miko here, this is Tyler here. The angle of elevation from the line of sight, this is 48.6 degrees, and this here is 50 degrees. Now what we want is the height of the pyramid. So imagine this is the pyramid. I'm not going to try to draw this three-dimensionally because I think it'll just make it more confusing. And then there's an extra piece of this. They say what the height is of both people. Now 6 inches, we know that 1 foot is equal to 12 inches. So that means that 6 inches is half a foot. It's half of 12. So that's something, I'm going to say that's 0.5 feet. That's going to be important to know that conversion because the height of both of these people is 5.5 feet. Now, here's the problem. We do have a right triangle. Actually, we have two of them. We have, here's the red triangle. But as you see, the problem is that we have an angle, and we're going to do sine, cosine, tangent, but we don't know this height, and we don't know this distance. And they're not the same because this is not a 30, 60, 90, or 45, 45, 90. So we have two variables here. Also, there's another right triangle. There's the one I'm going to put in green. Here's the angle, 48.6 degrees. But again, the problem is we don't know this total distance. We know this is 20, but that's for this small triangle here, and that's not a right triangle. So I can't do sine, cosine, tangent for this triangle. So right now that 20 is not very helpful. So the problem is that we have two pieces that are missing in both of these triangles. Now I'm going to call this y. I'll put that in red. That would be this distance here. Now that means that in the green triangle, this total distance, segment addition postulate, would be to add these, and I'm going to write that as y plus 20. So what's going to happen here is we're going to have to set up two expressions. So let's start with the red triangle. Here's the angle, the 50. X is the opposite side. Now, by the way, here's the other thing, is that X is only this distance. To find the actual height, I'll have to find X and then add the height of the two people, which is 5.5 feet. Okay, so there's a lot of pieces going on here that we have to realize. Opposite, this would be the adjacent side. So that would be the tangent, TOA. So tan 50 degrees equals the opposite, which is x, divided by the adjacent, which is y. Now, of course, we have two variables here, which we don't want, but at this point, that's what we got. So what I will do, I'll put that over 1. I am going to cross multiply and solve it for x. So we'll get 1x equals, and then this is y times tan 50 degrees, times the tangent of 50 degrees. And I'm going to stop for a moment with that equation. Now, for the green right triangle, here's the angle. Also opposite, also adjacent. So we're going to do tangent again. Tan 48.6 degrees equals, and the opposite is x, and the adjacent is y plus 20. If we solve it, I'll put this over 1 to make a proportion. We'll cross multiply, and we get 1x equals y plus 20 times the tangent of 48.6 degrees. And what I can do is distribute that. So x is equal to y times the tangent, 48.6 degrees, plus 20 times the tangent, 48.6 degrees. Guys, apologize, I'm running off my paper here. Okay, so this is where we are. Now, notice that we have x equals this expression, and we have x equals this expression. Now, since these are the same, if x is the same, which we're assuming, then that means this expression has got to be equal to this one. So I'm going to make another equation here. I'm going to say, I'll come over here, y times the tangent of 50 degrees equals y times the tangent of 48.6 degrees plus 20 tan 48.6 degrees. You don't need the little times dot there. You can just write them next to each other. All right, so this looks like a messy equation, but we only have one variable now. The variable is y, which is good. We want to move the y's to the same side, so I'm going to subtract y times the tangent of 48.6 degrees on both sides. Now, we can't combine those because we don't have the same tangent angle measure. So I'm just going to write it as y tan 50 degrees minus y tan 48.6 degrees equals, that's 0. So it's just positive 20 times the tangent of 48.6 degrees. Notice that I always write down my degree measure. That's really important because I just want to make sure I remind myself this is an angle measure that I'm looking at. Since both of these have y, what we can do is we can factor out that variable. That's a common factor. So we're going to factor out y. Now that's like dividing it out. So when I divide out the y, what's left in this expression is tangent 50 degrees minus what's left in this expression is tangent 48.6 degrees equals 20 times the tangent of 48.6 degrees. Now, I know that doesn't look great, but you have to remember that sine, cosine, tangent of an angle, it's just a number. It's going to be a decimal. So if I take my calculator and first of all, let me just check. Okay, I am in degree mode, so this is good. If I type tan 50 minus tangent 48.6, I just get a decimal. That's all that is. So we have y times a number. Now we want to move that number to the other side, so we need to undo multiplication. Well, the way we do that is we divide. So we're going to divide both sides. Now, you're going to be tempted to say that that's 0.06 and divide by 0.06, but I don't want to do that. I want to be exact, so I'm going to write this whole thing. So we're dividing by this whole expression here, tan 50 degrees minus the tangent of 48.6. Whatever we do to the left side, we have to do to the right side. Now it's a calculator problem. Because on the left side, anything divided by itself is just 1. So what we get is y equals. So now I'm going to type this, and most of your calculators will allow you to write this as a fraction. I would do that. So it's 20 tan 48.6, that is on top, divided by, it's the tangent of 50 degrees minus the tangent of 48.6 degrees equals, and we get y equals 394.7, I'm going to round that to the tenths place, feet. 394.7 feet. Now, just to show you, if you don't type it as a fraction, you can still get it. But tan 48.6 divided by, I'm going to do this wrong. I'm going to type tangent 50 minus the tangent of 48.6, and I'm going to get the wrong value. I get 17.9. Now, the reason I got that is because the calculator was only dividing by this value, but I want the calculator to divide by this whole thing. So when I hit the divide sign, I need to open parentheses, then I type the tangent of 50 minus the tangent of 48.6, close parentheses again at the end, and I should get, there's my 394.7. Okay, so it's a lot easier, I think, to type it as the fraction, because then I just type exactly what I see, what I've written. But you can do it the other way, just be careful. Now, we need to be careful, again, because this is not the answer. So that is the value for y, but we're not solving for y, we're trying to solve for the height of the pyramid, which means we need to find x. But we've done all the work here. We have two equations, x equals this and x equals this. Let's take the y value and let's substitute into one of the equations. Now the easier one, I think, is this one. So I'm gonna come over here. Let's take the equation x equals y times the tangent of 50 degrees. And we're gonna substitute the value of y, x equals 394.7 times the tangent of 50 degrees. Well, I don't need the parentheses there, but that's okay. Now again, I've rounded when I write 394.7. However, when I make my final calculation here on my calculator, I will use the previous answer. So the previous answer, sorry, I'll put that back up, 394 point, I want to do 0.6943236. I want to be as exact as possible. So I can take that answer times tangent 50. And we get 470.4, I'll round that to the tenths place, feet. 470.4, that is x, 470.4 feet. And we're almost done, because remember at the very beginning, each of them is 5 feet 6 inches tall. So this is them standing, this is from their eye level. What we just found was this, but we need to add their height at the end to find the total height of the pyramid. So h equals 470.4 plus 5.5 feet, and what we get, the final height, is 475.9 feet. And that is the end of that problem right there.